All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the summer 2022 semester at George Brown. And it's week 10, part one of our broadcast and recording. Again, in this semester, we have our lab that comes before our lecture. Lecture is going to be held on Thursday as normal. So this week, what we're doing is we're talking about state machines, and I just wanted to quickly go through this again. We talked about this last week. So last week we did decision making and decision trees. I showed you a couple of possibilities. We also talked about assignment 3, 4, and 5 really quickly. And we started off with Lab 6, Part 1, kind of get you guys warmed up and all that kind of stuff. And this week, what we're doing is we're doing Lab 6 Part 1 and 2. So Lab 6 Part 1 and 2 are both due this Sunday at midnight. That's week 10. As well, just on the docket. So when we look at stuff that's due coming up, Assignment 3, that's hot on kind of one thing that's hot this week coming up is it's due week 11. So not this week, but next week. And so Sunday, July 24th at midnight. So again, there's a lot of pieces that I don't need to give you for this for you to start going with it, as I discussed last week during our lecture recording. So that's where we are. We're sitting at week 10. Like we said before, we're talking about state machines. Next week, we're going into behavior trees. And like I said, from an evaluation perspective, we're talking about the first of two assignment parts. Assignment 3, and that's what we're working towards with your Lab 6, Part 1 and Part 2. That's what's happening so far. So what are we doing today specifically? Well, at the bottom of the PowerPoint, it tells us you can start with either Lab 6 Part 1 from last week, or use the Lab 6.2 starter that I provided for you up on Blackboard. And if you look up on Blackboard under Labs, there is the Lab 6.2 starter. That's everything we started with from last day, ready to go for you, just in case you missed. And we had a couple of problems, and that's why I don't have the Lab 6.1 starter up here. A couple of problems that we had was, one, we had a Rogers outage that affected a lot of us this weekend. Starting from Friday, some people lasted till Sunday, some people went even till Monday. Like I was fully up, and I think power was completely restored, and internet was completely restored for me, I would say, on Sunday. That's when I was completely up and going. So that's how long it lasted for me. And so as a result of that, I wasn't able to get up the recording that I kind of did for you guys, which I was hoping to get up earlier than that. And if you look at the content for the recording for last week, if you wanted to follow along, so week 9, I provided the recording for Lab 6.1 that's up there, as well as the lecture recording that I normally go and live broadcast as we go. So this live broadcast and recording is what's happening right now. So up on YouTube right now, like we said from last day, if you look at content in week 10, there is this link for Lab 1, from Lab 6.2, which is also live and being broadcast on the internet. Okay, so that's what's happening right now. So again, it's really up to you how you participate and how you you complete your lab. You can watch the video, you can participate live, you can ask your questions, and hopefully you'll be able to do that as we get going. All right, so that is the stuff we're doing today. So what is it? So you're starting with Lab 6.2. We're going to clean up the placing again. We're going to remove individual obstacle references this time around. And what we want to do is we want to load our obstacle data from a text file. This is kind of another thing that we want to do. We're going to also add line of sight information for each path node, depending on if you're a target, the spaceship, or both the target and the spaceship. And there is a student task for you to complete as well. If you actually look up on the lab report that I've shared on Lab 6, you'll see that there are a couple tasks for you to do for this Sunday. Let's kind of give you a preview of what this might look like. What the completed lab should look like, and let's take a look at that. So here's what the completed lab might look like at the end. So you notice that there is the ship, and we have the obstacle, and we can toggle the grid on and off. Notice now when I toggle the grid on and off, it's not just line of sight for the ship, but each of the nodes has line of sight depending on which object we're looking at. So for example, right now you can see that the active line of sight for each node is going from the nodes to the line of sight target. So for this one, so example would be, you can see all of these nodes are green, right? And these nodes that are green have line of sight with the target, okay? If I click on this one, this button, you're going to see that everything is red, but the stuff that's blue, these blue nodes, all have line of sight with the ship, okay? And then if I click on the last one, notice that this is active. If I click on the last one, you're going to see that only the light blue nodes here are going to have line of sight with both the ship and the target. And if one thing to note is if I move one of them around, let's say I move my ship position around, you can see that automatically the nodes would change color. And also you can see that I'm also having line of sight between my ship and my my target. Same thing goes if I was to move my target around. So let's go and take the target and move that around. So if I move this around, you can see that as well, those nodes change, right? So you can see that this is the target. If I move the target around, you can see that the nodes light up green when the nodes themselves have line of sight with the target. So this is what we're looking to accomplish today. You know, for the most part, stuff that we already have is this piece, you know, kind of how many targets. We need to update this in IMGUI and some other minor things. Okay, let's move on to getting it done. So for student tasks, you're going to draw a path. This is one thing that I want you guys to do at the end of this whole thing. Draw a path between the ship and the target using one or more nodes. And you may use any tools and utilities provided to you. So example, the util tools for drawing a line, you can do that. But we want you to draw a path through the nodes to the target. So why would we want this? This is kind of the beginning of trying to figure out, you know, how do I do that? How do I draw a path from one thing to the other? Okay, you could just draw, and if I'm just going to run this thing one more time so you can see it, you could have just drawn the final version. Might mean that you might, maybe there'll be a button that you can add in, draw a path, and it would draw a path between the ship and the target like this. So from the ship, the closest node to the ship, to this node right here, which is that has line of sight. This is line of sight from here to here, and then from here to here, and that would be your path, right? So you can move the ship from here to here, and then from here to there, right? That's the idea. So really it's two lines, from here to here, and then from here to here, as an example, okay? So that's what I want you guys to figure out how to do at the end of this. All right, so that is the goal today. Let's get cracking. We have a lot of stuff to do and always not a lot of time to do it. I'm going to start for you guys, just like you, with the Lab 6.2 starter that, again, you can find up on Blackboard. You can go to Blackboard and get that Lab 6.2 starter right here from Lab 6, okay? And I'm going to start with that too, just to be fair with you guys. So I'm going to grab this one, copy it, and I'm going to go into our desktop. And you guys are section 1, I think, or the first section. I did ask the other group to join us as well. I'm not sure if they remembered or whatever, but you know, hopefully you guys met with Philip today, and that was fun. I'm going to go into GAME3001 here. There's two sections, section 1 and section 2. I'm going to consider you guys section 1 because you guys are the first ones. And I'm just going to pile in that Lab 6.2 starter .zip. And what I'm going to do is I'm going to go to 7-zip and extract. So that will extract my Lab 6.2. I'm just going to get rid of this. And I'm just going to rename this from Lab 6.2 starter to Lab 6.2. And this is kind of your completed lab. For you, you might call this Lab 6, right? Because you're going to submit whatever we do today, plus your modifications for this thing here. So this is where I'm going to start. So let's run this. So here, one thing to note is, let me go back to that. If I call this a starter, sometimes zip archives do funny things. Okay, so let's suppose, you know, if I double click in there, you can see that there's also another folder within a folder. Sometimes it does that. So just what I would do is grab this, cut it out, so there's not a folder and a folder and a folder, and then just put it out here like this, right? And let's see if this is actually going to work. That sucks. I always run into these little like fancy little things. All right, one more time, one more time, one more time, one more time. Let's do that. So I don't care about that. This is just named wrong. This should be named 6.2. I'll be okay. And what we want to do is grab this thing, cut it, and go out here and paste it. I don't care if the previous thing if it messed up. There we go. Now I can get rid of this. Ooh. Oh, Tom. All right. And then let's just start this off here like this. There we go. Okay. So now that I've started, you guys may have started faster than me, hopefully. A couple things to note. We want to change this from x64 to x86 again. And we always want to run things to make sure we have, kind of a working project starting off. So again, if you're starting from last week, then you have a working project. If you're, kind of starting off from the starter, which all it does is it just fixed up some of those things that we had a problem for. That's why I recommended it. Then you'll have a working version of our nodes, and your starter, whether you had it working last week on your own or this week, should look like this. Let's see if it works. So I'm just going to run the starter here. And it's taking its sweet time. But here it is. So this is what we had from last week, this stuff, okay? And we also had this right here, and we could move the ship around and we move it into distance. You can see that it has line of sight now, right? So we have that working from last day. We could toggle the grid on, but they're all blue. And we can move the ship up to here and kind of change the angle and maybe move it over. And as soon as it's clear of the obstacle, you can see that it gives us line of sight with the target. Okay, that's what we had last day. Okay, so that's what you should have starting this lab. Awesome. Okay, great. So now that we have our starter working, let's follow the instructions that I've provided for you up online as well. So these instructions can be found again up online under labs. There is instructions part 2. There it is, lab 6 part 2 instructions. I left the lab 6 part 1 instructions up there, so that way if you wanted to do things from scratch, for those people who are watching, you could. It's totally up to you if that's what you want to do. All right, awesome. So that's what we're starting with. Let's take a look at some of those instructions and see what they tell us. So again, setup, use your finished project from lab 6 part 1 or use the lab 6.1 starter. We did that. Okay, our lab, it's actually the lab 6.2 starter. Next, you will add a new data filter to your project. So this is the first thing we're going to do. So we're going to go to our project. There we go. And if we don't already have it, we should have a data filter right here. And we have level.txt plus leveldata.txt that Alex provided for you. There is another file that is already in your project from the very beginning called obstacles.txt. We want to add that as an existing piece of data. So I'm going to right click here and I'm going to go to add existing item. And that's going to add in if I go back into the right spot for this. So again, one thing to note is you need to be in the right folder to make sure that it's right. So for me, it's GBC, GAME3001, Section 1, Lab 6.2, and in the Assets Data folder. That's where it is. And I want to go into obstacles.txt. I want to add that in as an existing object. So notice obstacles.txt has some obstacle positioning information. So again, notice that there is X, Y, width, and height information that's logged in the obstacles.txt file. Our goal for today is instead of using the obstacles that we manually put in, we want to modify things so that way, we have our obstacles files here. This is the starter. And what I want to do is like we normally do is I want to put this up on GitHub. Again, you can use your GitHub desktop, just like you've been doing with Alex, or you can use command line. And for command line, what I do is just put CMD or command line. And I showed you guys this, these commands before, but we'll do it again. I'm going to go into game section 1 lab. So section 1 has a .git folder, right? And this is the the thing that I want to do. So what I need to do is go into section 1, so cd space, and then section 1, and drag and drop that in. And once I've done that, if I do a dir, which is a directory, I can see lab 6.1 and lab 6.2. I'm going to do a git add dot. And git add dot, what it does is it adds all the new files or any changes to the staging area. And the staging area is me marking files in my version control, right? And then I'm going to do git commit -m, and I'm going to say added project files for lab 6.2. And that gives me all the changes and anything else I've added in. And then I'm going to do a git push because I already have my repository, and it's going to push everything up to GitHub for section 1. All right, so you can see it's going to take its time to do the initial push as we have some megabytes to go. So where is this for you guys? And again, if you're watching this in your section 1 or section 2, it doesn't really matter, because if I go to github.com and if I look at George Brown College, you can see that there is a GAME3001 M2022 labs, and that's where I'm uploading this video. Here's 6.2 right there. And so I'll give you this link just in case you need it to follow along. You can also ask me to push if that makes it easier for you as we're going today. All right, so that's the link, and I also put that link up on YouTube for those people who are watching on YouTube, and I'll just put that in the chat. All right, good. So that is lab 6.2. Okay, good. So now we've kind of completed this first part, right? And we're going into the next part, which is the placeScene.h. We're going to remove individual obstacle references from here, right? And we're going to rename the old check ship line of sight prototype to or function to a check agent line of sight. And we're also going to add some additional functional helper function prototypes so that we can do line of sight between our nodes and the ship and our nodes and the target, or both. Remember, I just showed you that as an example for lab 6.1. Okay, great. So let's try that out. So where do we do that? So again, I'm just going to shut this down for now. We don't need to see this, but I do need to see my scenes. And I'm going to go to my placeScene.h. And in my placeScene.h, I have this stuff, right? So I have a build obstacle pool, right? And I also have this check ship line of sight that takes a couple things. It takes in a display object, as an example, with the target object in its const, but it's called check ship line of sight. And we really need it to say check agent line of sight. So any agent. Remember that the target is also an agent, or potentially an agent, and so is other things. We can add any agent we want to look at, okay, for this one. So a couple of approaches. One is to rename. So we can kind of rename this. So right click, refactor, rename. This is an approach. And I can rename this to M_check agent line of sight. That is definitely an approach that we could use. Okay, I'm just putting up these things just to talk about this way of doing it. Okay, I could do that. Check agent line of sight, right? And press next. The other way is just to make a brand new function and then copy paste and then delete this function. So there's a bunch of ways to do this. I'm going to do it the second way. So for today. So I'm going to say, instead of renaming, I'm going to say, let's make a brand new function. It's going to return bool. And this way it doesn't break anything. And it's going to be called M_check agent line of sight. And it's going to be, let's pass in a couple of things here. I'm going to pass in an agent pointer this time around, and the agent pointer as well as a display object pointer this time around. Okay, so both the agent and a display object pointer for the target object. Okay, so this is where it's going to go. It's very similar to our check ship line of sight, but it's not as specific, which means we can do more stuff with it. Okay, I'm just going to make sure that we have all of the includes here at the top. We have our scene, path, node, starship, and target. And that's really all the ones we need starting off. Okay, so that's things that we need. All right, so that is the new function. I'm just going to make a separation here so we can see the new stuff. This is going to be earmarked as to delete. Need to delete this one. Okay, I'm just going to come back to this. And whenever you could do a to-do in Visual Studio, it'll mark it like this. We have to add some additional functions in here to help us out. So the other one we're going to add in is a void, Boolean m_check path node line of sight. So path node and agent. So more specific, we're going to pass in a path node pointer, which we're going to call path node, as well as a display object pointer, the target object. So we're going to have both. Okay, that's kind of something we need. That's a new one. And we're also going to have a void, which is m_check all nodes with target function. And we're going to pass in display object pointer and the target object that we're trying to get a line of sight with. And one more, we're going to also have another one that is check all nodes with both. Okay, that kind of gives us both the agent or the ship and the target, right? And we also want to m_set path node. We don't have this yet. Path node line of sight distance, which is going to be an integer, whatever that distance is going to be, because each path node will also have its own line of sight that we're going to set up. We also want to have a switch, some kind of switch that we're going to use. So we're going to have an integer that we're going to use as a switch, which is going to be called m_line of sight mode. We could convert this to an enumeration later on, where 0 is the nodes visible to the target. 1, and again, we may convert this later if we have time, nodes visible to the player. And 2 is equal to nodes visible to both. So we're going to convert this to a thing later on. We have a clear nodes method, which we're going to keep, right? And I'm also going to have an integer that I'm going to house here for the it's going to be called m_path node. We're going to keep track of this line of sight distance that we're going to use to keep track of the line of sight distance for all the path nodes. So those are the changes to my .h right now. And I'm going to save this and put this up. No, it won't. It won't filter them because files under the bin folder. Yeah, well, you know what, Derek? I think I included that. If you use the default gitignore file that we've given you. So if you look at the gitignore file, right, you're thinking about if we were using the built-in gitignore file from Visual Studio. We're not using that. So if you look in the gitignore file for Lab 6.2, this is the gitignore file. And if I look there and press edit, then inside there, you can see the files that are omitted. And one of them that we don't omit is the bin folder. So the bin folder will be included, not removed. Same thing with the debug folder. The debug folder will be included, not removed. Typically what happens is Visual Studio supplies you with the .gitignore file, and we've modified it. So please use the files that we've given you, and you should have no problems. Okay? All right, so let's continue with this insanity as we move on. This is a great place to put this up on GitHub because we modified, if you look at our notes here, we did exactly the placing.h. We did all those things to help us out. So this is our next commit. Let's commit. So again, I'm going to bring up my command prompt. You can do yours through GitHub desktop. And I'm going to go here and say something like git add dot, git commit -m, and we'll say modified placing.h. And then git push. Well, okay, everything up to date. Well, how come? Because of this. See, this thing here hasn't been saved? We have to save it. Save, right? And try again. If you ever have that problem, you can always do the same thing, the same group of commands again. Git add dot, git commit -m. There it is. There's a modified the placing. One file changed. And then finally, Git push. We can do those as many times as I want. If I'm not making a change, Git will tell me right on the command prompt. There we go. It's ready to go. So we've done our next commit. So our GitHub is up to date. Great. Now that I have this, it's a good time to put these to use Visual Studio to attach them. I'm using ReSharp or C++. So again, I'm going to go generate declarations by, that's what I want to do. So if I go here, and if you know the light bulb comes on, it says generate definitions by declarations. And if I do that, it's going to give me a little bit of a dialog box that allows me to add the things in here in the right order. I'm going to click finish. And what this is going to do is it's going to add in these stubs. These are all the function stubs that I have to do for this for today. Okay, so this is starting off modifying my CPP. All right, we have a check ship line of sight, and I want to start with this first because what I want to do is I want to modify check agent line of sight. So we change it to check, so the check ship line of sight works. Okay, so I want to grab this part, the whole thing, all of this to start, leaving the check ship line of sight in play still. And I'm just going to paste it inside of the check agent line of sight and do some heavy modifications. Okay, so that's the first thing I do. So again, what I want to start with at the top, we probably modify this to death, but we're going to start off with a Boolean, which we're going to say up here has line of sight. Has line of sight, we're going to start off with as false. So that's where we're going to start with that. So this is the default for the agent. Default is no line of sight. And we're going to say that whatever, instead of the starship, right, directly, it has to be the starship. This way we can use any agent, not specifically the starship. Our previous function that we had before was only for the starship. Well, imagine if I had to do this for other objects in the game. I'd have to do another function that's very similar to this for every object. We want to make a generic function that works for every agent, and that's why we're doing this like this. So let's rename any references to starship. We want to rename this to agent. So agent is what we want to change here, right? And I want to do that for all references as we go. So agent, we want to set line of sight, and we don't want to set it to false. We want to set it to a has line of sight, right? So we keep track of the same thing. Okay. And we're going to start doing the same changes as we go. So agent is what we want to use every single time. So okay, if the ship to the target distance is less than or equal to the line of sight distance, that's the range. Then what we want to do is the ship to range, that's the ship to range, or ship to, we also can call this agent to target distance, or whatever you want to call it. So this is something we can rename, we kind of refactor rename this one, refactor rename to, and we'll call it something like agent to range, agent to range. The reason why I'm saying range is really what it's calculating is the object in range or not? Okay, if the object's not in range, then we don't have to check because it's out of range. In other words, like the weapon that you're trying to fire doesn't have the range. Maybe you're casting a bow, using some kind of spell, or you want to use some kind of laser weapon or something like that, but you don't have range. It kind of runs out of juice after a certain point. That's what this represents. And what we want to do is we want to get the closest edge from the agent this time, right? From the agent, to the target object. That's what we're checking. And if my agent to range is less than, and again, we don't want to put in starship, the agent is what we want to say here. Agent to get line of sight distance. Again, we're just rewriting this this code here. We're definitely in range. That's the first thing we want to know. And what we want to do is we created a standard vector of display objects called the contact list. That's all good, right? We're going to do a for each loop for every display object in the display list. And then things start to change. So what I want to do, it's almost identical, but what we want to do is we want to create a inside of the first check we're going to make, which is, so again, we have an if statement, we have a for loop, And then after the for loop, we want to do a check up here. So this is the first change. We're going to say that we're going to make a const auto, and this agent to line of sight distance, instead of putting it inside of here, right, which is the ship to object distance, this thing right here, I'm going to move this idea, this thing here, let's move it, and let's teleport it so that it is here. Okay, that's what I want to go up here. Ship to line of sight distance will be outside of the if statement, not inside the if statement, and there's a reason for this. So we'll calculate the ship, but it won't be called ship. We'll rename it to refactor rename, and we'll call this the agent to object distance. So agent to object distance. That's what we're going to call it, agent to object distance. And the agent to object distance is going to go from, instead of the starship, it's going to go from the agent, whatever that agent happens to be. Again, it's more generic this way. That's why we're not specifically saying starship. From the agent to the display object is what we want. Okay, so that is the exact same code, just moved up here and renamed. Okay, next. Okay, I'm going to just kind of hide this part so you can see more of it up here. So that's the first line. Next, if notice it says display object here. So for every display object in the display list here, we were checking display object if it's not an agent and stuff like that. Here, this is where this stuff is going to change. So I'm going to just wipe some of this out and recode it because I think it's just easier to do. It's going to be very similar to this, and we're going to see what it looks like in a second. Here's how it looks, okay? I'm going to say if again, it's agent to range. If my agent to range, this one, is greater than the agent to object distance, right? So let me make sure I have everything. Yes. Actually, it's going to be the other way around. We're going to do this one. So we're going to say if my agent to object distance, this one, if it's greater than, right, my agent to range, so it's farther out, too far, so we don't have, we're out of range, and we're going to just continue. So this is that we're out of range. Let's put curly braces here because I don't like doing it like this. I'm a curly brace person, all right? And we're just going to say target is out of range, okay? So the agent to object distance, agent to object, is greater than the agent to range, the range itself. So this is kind of where we're out of range here somehow. And it can happen even if we did our check up here. Okay, even if it happened, that can happen there. So we're going to put that in there as continue. Okay, so that's going to be the first check. Next check we're going to say is if our display object, there's our display object, get type, if our type is not equal to agent, if our display type is not equal to agent, right? And of course we want to use this one, game object agent, this one. Then, and here's the next part that we're going to do, our display object get type is not equal to a path node. We can kind of do a search for this. So path node, this is that, path node, okay? And we also want to check, not just for path node, but we also want to check if it's not the target. So if it's not any of those things, we're going to make sure it's explicit, and our display object, kind of get type, right? Display object is not equal to our target, right? So notice we have a path node, an agent, and we have also a target right here. So if it's not any of these, so agent, path node, or target, it's got to be an obstacle. All right, so this is kind of a funky way of doing it, a roundabout way, but we could say if it's an obstacle, right? But what if it's not? What if it's something else? So it's not a path node. It can't be an agent, it can't be a path node that we're looking at, and it can't be a target, right? Then it must be an obstacle. If it's an obstacle, then I want to add it to the path to the contact list. Let's add our display object to the contact list. That's what this does. So that's the modification that we're making, okay, for agent so far. All right, next, a couple of things that are going to happen here that are different, okay? Because notice we were supposed to return a Boolean, but we haven't returned one yet. Let's just get rid of this for now, and let's recode this part as well. So after the if statement's done, the for is done. So after the for loop, we're going to do a const glm vec2. We're going to say that that is going to be called agent endpoint. So agent endpoint is going to equal to the agent, right, where we're going to get transform dot position, and we're going to add in the agent, whatever the agent is, and then get current direction. So get current direction, this one, just like we did before. And then we're going to multiply that by the agent get line of sight distance. So remember we did this last day. What this does, this agent endpoint, right? If you think about what this is, it's called agent endpoint, but really what this is the endpoint to the line of sight itself. So this is the agent line of sight endpoint. Let's just rename this agent line of sight endpoint, okay? So the agent line of sight endpoint is that last point on the line segment between the agent itself and the endpoint. One thing I did also is when I did it the last time, when I said has line of sight for the target distance, right? What we did was we when we calculated what this thing was, this agent line of sight endpoint, we can also, here's the endpoint. Notice that the endpoint itself is the position plus the current heading and the direction, kind of like what we did before, but we started at the starship. We don't necessarily need to start it at the starship. We can start it ahead of the starship a little bit as well. I talked about that in the second section for those people who are watching the second section from last day. All right, the next part. I want to have a set that has line of sight. Has line of sight then is we're going to use the collision manager, and we're going to say collision manager line of sight check, and we're going to go from the agent, right, to the agent's line of sight endpoint, this part that we just defined, right? We're going to pass in the contact list. Here's the contact list and the target object. So that is kind of just another way of rewriting what we had earlier, right? We can also define the line of sight color. So line of sight color, we can say, and I think I missed that. Maybe we kind of define that up here as well at the top. We can say a GLM. Here's something we can do, a vec4, where it's called line of sight color. Let's just define that up here. GLM vec4. Yes, I wanted to do that, of course. Thank you, Visual Studio. So line of sight color, then what I want to do is I want to say that that is equal to the target object, right? Get type. And if that is equal to an agent, so this one, if it's equal to an agent, this is a little ternary operator, then we want to say we want to return a vec4 that is 0, 0, 1, 1, right? If it's equal to an agent. Otherwise, if it's not equal to the agent, if it's something else, we want to have a vec4 that is 0, 1, 0, 1, a blue one. That's what we're going to say. So that's our line of sight color that I'm going to set up. And then what I can do is I can say agents line of sight, or set line of sight, and that set has line of sight is going to be equal to the has line of sight variable we just made plus the line of sight color we just defined, depending on what that is, okay? But notice that it gives us a bit of an issue, because right now set has line of sight only takes in has the state, but doesn't take in a color. We're going to fix this in a second. Okay. What I'm going to do is I'm also, to finish off this function, I'm going to return has line of sight. And that's going to give us the ability to return a Boolean to know if we have line of sight or not. That's the first step. So we need to fix this problem, set has line of sight. And let's go and fix that now, right? And what we're going to do is we're going to go right click and I'm going to go to definition to fix that problem. So right now we only have one definition for set has line of sight. It's just this one. I want to give my agents, so in my agent.cpp, it only has this one. I want to give my agents the ability for me to pass in a color I want them to have as well, okay? So not just for it to set its own color, but for me to pass in a color when I do the line of sight, just to give me some more flexibility. So I'm just going to pin this up again. And I want to go into the agent, agent.h and add that function in there as well, all right? So again, if I like a core and I go to agent.h, there's agent.h, you can see that I have a set line of sight color, right, as an example, that only takes in a color. And I also have set has line of sight that only takes in a state. I want a set has line of sight to have an overload. Here's the overload for agent. So I'm going to say void. We're going to also define a new function in the agent.h, which is set has line of sight. That's going to take in both a state as well as a GLM vec4 for the color. Okay, that's what we want as well. So that's what all agents will now have, an extra bit of information in their set has line of sight. Okay, so I'm overloading this function so that in my placing.cpp, it's going to work. See how it works already? It's not really defined yet, but it takes away that error. So I'm going to go back to my agent.h and I'm going to define this now. So I'm going to go right click and I want to kind of generate that definition, which is going to give me a little stub that looks like this in my agent.cpp, right? So it's exactly like this one, but this one here has a few more things. So we're going to say M has line of sight. That's still true. It's going to have state. But instead of line of sight color being random, I'm going to say M underscore line of sight color, right, is going to equal to, similar to, actually, let's just copy paste this piece here. Should have copy pasted everything just to make it quick. It's almost identical to this, but, right, what I want to do is I want to pass in either the color, if it exists, so this is the color, right, or if it doesn't exist, just pass in a red, right? So this is red or whatever the color I want to pass in there. And when I do this, it's more comfortable that I write in this as const. And if you think about this, const bool state and a GLM for color, right? It doesn't care if it's const or not. How could I rewrite this thing? Because there's quite a bit of duplication where I want to add in this piece. I want to almost like use this set has line of sight option, right, with the state, because I'm just rewriting this same thing. I could rewrite this thing a little differently. I could call the original function, right? I could say set has line of sight. It takes a state. I could pass in my state, right? So whatever that is, and then I can define my color my own way. The problem is then it's going to try and rewrite it again on its own, because that's the way I've written set has line of sight. So if you were thinking about writing it by calling the original function, not really that possible. All right, so that's why it's written like this. So it's almost identical to this one. The only thing is I'm actually allowing the user to pass in the color they want, as opposed to always being green, because this is red, green, blue, and this is red, right? So this is green and this is red. But what if I wanted to pass in another color like light blue or whatever? That's what this set has line of sight does. Okay, so it kind of sets the line of sight color at the same time, as opposed to doing it in two steps. All right, so that is my modification to agent.cpp for now, and my placing works perfectly with my check agent line of sight. This is the first thing. I'm going to put this up on GitHub now because I've added in my check agent line of sight. So up on GitHub, I'm going to say git add dot, git commit -m, and I'll say added check M underscore check agent line of sight definition. Git push. Okay, so that kind of does that. So we have that definition working. We haven't tested it yet, but that's the first part. Let's define my other stuff. So we have this one, and we haven't deleted this one yet. The check ship line of sight is still in play. Okay. Next, I want to do the check path node line of sight, and let's see if there's something that is similar between the check agent and check path node. What's different? What's the same? So check path node is actually a little shorter. It looks like this. We want to check the angle to the target. That's what we want to do. So we can still use line of sight distance for path nodes. Okay. So how does this work? So we're going to say const auto, and we're going to use the target direction, whatever that direction is going to be the target object, right? And the get transform dot position. So whatever the target object is, this is the target direction, the direction to the target from the path node, minus whatever the path node is, right? Get transform dot position. So remember, when we want to create a vector, a direction vector, this target direction is actually drawing a line. I'm just going to draw that line. So imagine if I have this is the node, and this is the target. Let's draw the target as a circle. So if this is the node and this is the target, what I'm doing is I'm saying take the target location, which is this location right here, and I want to make a subtraction from here, this location to this, which gives us a line that goes this way from the target T, to the path node P. Let's say as an example, right? Here's the path node, right? We don't want this entire line. We just want a normalized vector that points to the line. Okay, that's what we want. So what we really want, if this was the scenario, right, is here is our path node, right? And here is our target. We just want this, a unit vector that points to the target location, right? That's what we want. So here's the path node, here's the target. We don't want that entire line. Okay, so the way to do that would be to normalize this function. We have a normalized function that we're going to do. So we're going to say const auto. We're going to call this normalized direction. The normalized direction is the actual direction itself, but we're going to use the util normalized function. The util library has a normalize function that we can pass this into. So normalize is going to take the target direction and reduce it to a unit vector. So changes direction to a unit vector. So again, length of 1. That's what it means. Okay, unit vector means I'm pointing to that location, but I don't have the entire magnitude. And then what I want is the path node. I'm going to take the path code and I want to set my current direction for that path node to the normalized direction. So that's what the path node does. I can set the current direction, what the path node is looking at, right, to the normalized direction from my path node to the target object, whatever that target object happens to be. So this is kind of a generic function we're going to reuse. And then next, what we want to do is we want to return the M underscore, here's the beautiful thing, check line of sight agent line of sight, this one, where we pass in the path node as the agent object and the target object as the thing I want to check. So now for the first time, we're using the check agent line of sight method, which is going to be used right from the check path node line of sight. We're treating the path node as an agent object. Okay, let's put this up on GitHub. So save, and I'm going to do this, and I'm going to say, git add dot, git commit minus M, and we'll say added definition for M underscore check path node line of sight. Okay, that's that definition done. Got a few more to do to get going on this. So we want to also be able to check, all nodes with target. Check all nodes with target is a short one as well, where we're going to say for each. We want to do a for each loop. A for each loop does everything in the m_p grid. So every node in the grid. That's what we're going to say here. So for every path node in the grid, every path node in the grid, we want to perform that check. We want to say m_check path node line of sight. Isn't that a beautiful thing? Where we pass in the path node and the target object, whatever the target object happens to be. All right, so we're actually using this now, but we're doing it here. Okay. This likes to be made probably const auto, which is okay to do. Right, save. And we can put that up on GitHub, but I'm going to do, these ones are kind of shorter ones, these ones here. So we'll do them all, and then we'll put everything up. We'll put the helper functions up on GitHub. Okay. Check all nodes with both. How does that work? Again, it's another for each loop. So we're going to say for every, it's going to be in the grid again, m_p grid. For every node, for every path node in the grid, for every path node in the grid, when we check nodes with both, right, it's going to be this. We're going to have a Boolean that's going to be line of sight with Starship, okay? And we're going to say m_check path node line of sight from the path node to m_p Starship. Okay, so this is where the check is going to be. And Boolean line of sight with target, that's going to be equal to m_check path node line of sight, as an example, from the path node to the target. Okay, that's the two Booleans we have there. And then we're going to say the path node, for it to have line of sight, is going to have, we'll set the has line of sight method, we'll pass in where both are true, where both the line of sight with Starship is true and where the line of sight with target is true. Both those things are true. Then we're going to pass in a color value, glm vec4, where the color is blue. Or actually, it's a mix of blue and green. Okay, so that light green color that we saw earlier, or light blue color, all right? So both green and blue together, all right? That's what that thing is going to be. Let's check all nodes with both, all right? Check all nodes with target. We just kept the, we checked the path node and returned, we're going to return true. We're going to check if each one of them has line of sight. That's what we're going to do, okay? And then finally, the last one is set path node line of sight distance. This is an integer that we want to set. And what we want to do here is we're going to say for each m_p grid, and we're going to call this the const. We're going to fix these up in a second. This will also be a path node. For every path node in the grid, I'm going to say that when we want to check the line of sight distance, we're going to say path node set line of sight distance to, we're going to static cast the distance that we're going to get in to that line of sight distance. There we go. And it's complaining because path node in this case and path node in this case could be made const. So let's do that. So we're going to make this const. We're going to make this const. And over here in this function, it says, might as well make this const because we're not doing anything with it. Make that const and make this const. There we go. So we've kind of made all those things const. Line of sight with Starship, line of sight with target. And the distance can also be made const, right? Add const to this part. This is all safety stuff that we're being told to do. Okay. So that so far is what we've got inside of this. And that's going to give us the capability to check all those nodes. Let's put this up on GitHub. So again, we're going to say git add dot. git commit -m, and we're going to say added definitions for helper functions. Git push. Okay, so that gives us all the stuff that we have there for all those. And that is a good place to review what we've done. So again, why do we do all this work, right? Because remember, what we wanted to do is, what we want to accomplish at the end is something that looks like this, right? So where we have the ability for us to toggle between these options. This is what we want to do. So we change the color depending on if the node itself has line of sight with the target or the ship or whatever. Okay, that's how it's going to look. So that's why we made these functions for us to do that. And if I look back here at our notes, then we added all the other line of sight helpers. In the H, we needed in the placing.cpp, we didn't quite do everything, okay? But we also have to do the update and a bunch of all those things too. So in the .cpp, we did a lot of those functions. We kind of defined all those helper function prototypes and all that kind of stuff in the CPP. Okay, so that's what we did. So now we're into this piece, and we're going to kind of modify the CPP further by adding fstream, because we're going to start reading from a file instead of reading from manually putting in everything inside the scene itself. Okay, so that's the first thing we're going to do. So again, going back. So I'm going to go back to this. And this is nice. By the way, you can still run this. It didn't break anything. If I was to run this file right now, nothing changes. We haven't really broken anything because all we've done is added new files. And we've modified the agent class a little bit. But for the most part, you should still be able to run things. And there should not be any kind of, break in the code. It should still look like this. And it should be able to still toggle this on and off. But there's no color yet because we haven't modified the update function yet, which is what we're going to do soon. So that's what you should have right now. All right, on that, let's go to the top of our .cpp and notice that we have our if game and input and whatever. What we want to have at the top is I want to include information for fstream. And a couple of things, okay? So we have a couple of things required for the scene that's up here. There's some stuff that's required for IMGUI. And there's going to be some other stuff here. So we can actually group these a little differently. If I want to say required for the scene to run, right? If I want to say required for the scene to run, we definitely need the renderer and the util as an example. These two things probably are required for the scene. We need these things here. So the renderer and the util. We have our play scene in our game, an event handler, and the input type, all those things. Path node is probably something we don't need, but we've kind of included it. That's also something we need for the scene. I'm just reorganizing these includes for now, okay? And it'd be nice if we had access to the config. So include config.h, things to prepare, as well as let's include a fstream. Okay, so fstream is going to be able to give us the functions for, kind of writing and reading from files. That's what this is going to do. Okay. Fstream, save. All right, so there's our play scene, and we have our draw. And what we're doing with the draw right now is we're drawing. Notice what we have here is we're drawing the collision boundaries for.
Someone is at the front door.
Someone's always at the front door when I'm teaching. All right. We have the collision boundaries for the obstacle. Remember, we did this last week as a test, right? To see if the collision boundaries, if I just kind of run this thing again to show you what this means. The collision boundaries are these things, these little green boxes that are kind of around the red boxes, right? Well, what we want for this is for it to be toggled only on when the grid is toggled on. So we can check for this. If we're going to use this kind of debug mode, right, then we only want to check this for loop if the grid is toggled on. So we can say if m underscore, and if I just do toggle grid, because we know that if the toggle grid is on or not, so if the grid is toggled on, right, So M underscore toggle grid on or off, if it's true, how do I check to see if the grid is on or not, right? Do we have a member variable for that? And if I look at the placing.h, we have is grid enabled. That's what we have. So we're going to say if M underscore is grid enabled. If the grid is enabled, then show me the debug information in the draw function. Otherwise, don't. Okay, and by the way, it's telling us we can probably make this thing const. Okay, so far that's what we're saying. Okay, and if I was to run this thing again, just by that little simple change in my draw function, I know, right? Then you can see that there's no boxes around these things, right? But we also don't have a box around this, and we don't have a box around this. We don't have these things, these little boxes around these things, right? So it's good to know that if I was to put the grid on, notice how the boxes appear around here, but there's no box around here, or no, kind of debug information, and no debug information around this at all. We can maybe change that later. For now, it's not going to show this part unless we need it. In the update function now, we need to make some changes. Okay, so here's the big one for the update function. We definitely want to update the display list, but instead of doing this check shipped line of sight stuff, that doesn't work anymore, right? We don't want to do that simply like this. We want to do something different. We want to say M underscore check agent line of sight, where I pass in M underscore P starship and the M underscore P target to the agent line of sight. That's going to be the agent line of sight. And then I want to switch based on our M underscore line of sight mode, when we get to that, where I'm going to say case 0 for now. We're going to modify this and add some, again, some kind of enumeration. Case 0, case 1, and case 2. Remember what we said? And it's kind of, that's why we use enumerations. Case 0, which means the target, we're going to say M underscore check all nodes with the target. If all nodes with the target is, we're going to pass in M underscore P target. That's the target that we want to check. So target is by default what we're going to check with. The other one, case 1, is M check all nodes with target, and the target in this case is going to be this starship. So the target could be the target itself, or with the spaceship or the starship. So this is the starship. Okay, and then finally, M underscore check all nodes with both, right? Check all nodes with both, which is both target and starship. Okay, that's what this little switch case does. Again, we're going to modify this eventually so that we don't have 0, 1, 2. We actually have some enumerations, but for now, I just want to get this going with you to see how it works. Okay, so we've just made a change. Let's see if does this do anything. One thing to note is line of sight mode has never been defined. M underscore line of sight mode. And we didn't define it inside the constructor function. So we should be careful because by default it's 0, but we should probably define this somewhere in the start function to get going with, right? That's kind of the first thing we should do, right? Otherwise it's going to crap out or potentially crap out. Let's go to start. And in our start, just like we have our placing should be lab 6 part 2 at this point, or lab 6 by itself if you're just you. What we want to do is in our setup, right? We set our input type. We added some game objects, but we want to set up a few more fields for us as well. So I'm going to do this right underneath here. So I'm going to say, let's set up a few more fields. The first one is M underscore line of sight mode, which we'll set to 0 by now. Again, this is a future, for sure, a future enum. Okay, we don't want to leave it like this right now. This is just kind of postmarked. And then the M underscore path node line of sight distance is going to be set to 1,000. So that means anywhere on the screen potentially, that's 1,000 pixels, 1,000 pixel distance. That's what this means, okay? And we also want to m underscore set path node line of sight distance to the m underscore path node line of sight distance, this one. That'll be okay. Typing is weird. And those are a couple of fields we want to set up beforehand. Okay. We also know that by default, the grid is disabled. So we kind of did that down here, right? We set up the grid and all that kind of stuff afterwards. And we built the grid and we toggled the grid and all that stuff. All the same things. We haven't removed the obstacles. What I want to check right now is just that my changes with what we did with my check agent line of sight are working. Okay, so let's do that. So I'm going to run it. And let's hope it doesn't break. And if it breaks, then we'll be able to fix it. So this is our first bit. If I turn on the toggle grid, now you can see this. You should see this part. And not only that, but if I move, you should see that it's almost looking like a shadow or a light is being cast from the target as an example. One thing to note also is that when I move my target, this is kind of a glitch, right? See how the grid is on top of my target, but my target should be on top of the grid. Meanwhile, if I move my ship around, you can see that the ship is on top of the grid, but the target is underneath it. That's a glitch we didn't accommodate for last time. So let's change that. So the way we can do that is for the target. Remember, we added in everything here, and our ship is on layer 2, right? And what we can specify is that our target is also on layer 2 if you really want to. Okay. We can choose whether a layer higher than the grid. The grid is going to be cast in second. So if I did that, if I go back to this, then theoretically, we should do the same thing, right? And we should be able to move our target around now. So here's our target position. And it should not be, because we're redrawing the grid every single time we do that, it should not be on underneath the grid, but rather on top of the grid. Okay? That's how it should work. And notice that that works. So it's like it's casting a light. The red area, right, is the area that does not have line of sight with the target. But notice that there's some spots, like this spot right here, that does have line of sight. And the way to check this is if I use zoom to annotate, I'm just going to draw a line. And let's see if you can see it as well as I can. So I'm going to draw a line from this node, the middle of this node here, right, to the target. Can I draw a line without it being interrupted? And you can see that, yeah, for this one, we're pretty good. But we're not good from this one, right? Not good from this one, this one. We are good from this one. Take a look at that, right? We're not good from this one. We are good from this one. And that's what these things do. They draw a line from the node to the target, right? So again, from this one, looks like it should also have a line. We can do something that looks like this. So you can see that you should be able to draw a line from any one of these things, right? Any one of these nodes have line of sight with the target, okay? That's what it does. Nice. And that's the first part, okay? The first part of our little job here. And you should have that too. So my question to you guys now is, if you can put this up on in the participant panel, is, are you with me? So Marco is with me. So Vander says, Tom, sorry to interrupt. Did we set M underscore check agent line of sight as a bool or a void? Bool. Right. So if you look at the .h, we set two things as bools. We set the check agent line of sight and check path node line of sight as both booleans. Okay. So hopefully that's good to go. Anyone else? Are you guys, how about Ali or Derek? Are you guys good too? Did you guys get this same thing? So Marco is good. He's watching. Derek's good. Do you mind going back to the update function? Sure, I can do that. So here's the update function. Let's just jump there. All right, so here's the update. But the update function is literally just a switch case. And it's ugly switch case because there's no enumeration with this. Okay, so this should give you an idea of how we do stuff. So it's kind of neat. Once we have line of sight with each of the nodes, guys, this is going to help you with your assignment 3. Why? Because if I have line of sight, then it can help me understand how to do those things. It's going to be the foundation for everything you're doing for assignment 3 and assignment 4 with this kind of stuff. Okay, that's the idea behind this. Ali, are you good? Can I move on? All right, so that's the first part. Let's put this up on GitHub. So we're going to say, oops, git add dot, git commit -m, and we'll say, we'll say tested new line of sight functions. Git push. All right, that's what we kind of did. We also can remove now, we can also remove the function that's not used anymore. The check ship line of sight function can be removed. We can do that because guess what? We don't need it anymore since we're using check agent line of sight. Okay, that's one thing we can get rid of. And let's go into the placing.cpp and make sure there's no other calls for that function. So if I go here, you can see that there's some calls for that. Why? Because the check ship line of sight is not defined or not declared. We can get rid of this whole piece of code here because it's no longer required. Okay, so that's the one piece that we want to get rid of. Okay. At this point, before I move on to loading stuff from files and all that funky stuff, let's add some additional things in the UI function to make this go. So I think we got time for that. So let's move to way down here to the UI function, so GUI function, right? And let's go through it and make sure we have everything we need, right? So we can toggle the grid, that's nice. And now we need a couple of additional things here when we toggle things on and off, right? So I'm going to add those in now. So after the IMGUI separator for, and before the spaceship properties and all that stuff, let's add some more stuff in here. So now, first thing is we're going to say if IMGUI, and then I want to add in a button, and the button is going to have node line of sight to target, right? So that's what it is. And we'll also give it a beautiful thing with buttons is you can give them a size like 300 by 20, let's say as an example. If that's true, then m underscore line of sight mode is equal to 0. So we can kind of align a button for this. We could also have made a radio button as well, where I can select radio buttons, just kind of like what I did up here with radio buttons. We could have done that too. So radio buttons instead of buttons. We'll do buttons instead, just to give you that same look and feel. Okay, so that's one. And then we can say if m underscore line of sight mode is equal to 0, well then let's make a IMGUI same line, oops, on the same line. Let's add in another little text file, IMGUI text, like a label that's going to say active. That's, remember what I showed you earlier with active, if this is true. Again, I want you to think about ways of making this better, but we're just going to make it work. So this stuff here is kind of the same thing I want to do over and over again. So you can see me repeating some of this. So I want to take this and then do another one. And the next one is going to be, instead of node to line of sight target, we want node to line of sight with spaceship, starship. Okay. So we can say node line of sight to target. How about that? Node line of sight to starship, right? And again, it's the same size. And instead of it being 1, we'll say that it's 1, like this. And I want you to think about how to redo this in a second. And then finally, one more time, it's kind of a silly thing to do, but we could say node line of sight, line of sight to both. All right, to both target and the ship. And we're going to say this is number 2, where this is active. Okay. The other thing that I want to have in here is I want to define my path node line of sight distance so I can increase or decrease how far each path node can see. This is for us to have some flexibility. So I want to make a slider int, and I want to call this path node line of sight distance. So for each path node, how far can they see? And I want to pass in a reference to m underscore path node line of sight distance. And I want to go from 0 to 1000, where 1000 is the default. And I'm going to say m underscore set path node line of sight distance to m underscore p path node line of sight distance. Depending on what I change it to in the slider, that is what this is going to do. So those are the buttons that I've added in. The rest is staying the exact same. So this part here, from starting from this IMGUI separator under the grid enabled part, all the way kind of down to the spaceship properties are there. I want to add a separator at the bottom. So I'm going to say, I'm just going to grab this separator up here. Again, this is just to make our IMGUI nice looking. I'm going to separate this, put the separator down here, and then now we can be able to test all the other functions out too. Let's run this thing and see if it works. Let's see it, and if it does, we're going to put this up on GitHub, and we're good to go. All right, so if I bring this up, right, you can see now I have these little buttons here we just made. And I can say, well, if I want to say, let's bring up the toggle grid. And if I go here, then you can see now we can see the blue color. The blue color represents line of sight from the node to the starship, from each node to the starship, right? And if I go node to both, you can see that that is that weird color that goes to both. Those are both node and the starship. And this, my friends, is part one of what we want to do with our path nodes. So path nodes now are intelligent. Path nodes give us information about, do they have line of sight between the node to target or node to line of sight. I can kind of do that. And let's say node to starship. So these blue nodes have line of sight to the starship. And if I move the starship around, so let's say I move my ship position, you can see that that changes, right? So depending on where these obstacles are, if I move the obstacles around, right, you can see that some areas are red. Red means no line of sight, and other areas are blue. Okay? So let's move the bottom one. Oops, the bottom one. So you can see that all those areas are red, and these areas are blue. Okay, so you should be able to see that kind of stuff too. All right, let's put this up on GitHub, and I'm going to ask you while I do this, are you with me? So git add dot git commit -m, and then added IMGUI controls. So I see Marco's with me. How about Derek and Locke and Vander, Ali? Ali says he's good. So Marco's good. So why am I showing you this? Because this is part of where we are right now. We're sitting at the play scene, and I've added in some stuff in the GUI function. So I kind of jumped ahead and I did this part. And the reason why I wanted to do that was because I wanted to make sure that all of the line of sight was working. And right now, the next part is I want to make sure that we remove individual obstacle references and add them in from a file stream. Okay, that's what I want to do. Thanks, Derek. Thanks, guys. And this is kind of the last bit that I want to do before I leave it to you guys to do the next part. Okay. And maybe some modifications to the enumeration like we talked about before. So remember right now how it works. If I go to the start function, what I'm doing right now is I'm adding individual objects. Here's my objects in here. And I have a build obstacle pool where I kind of build up objects one at a time. And this is nice, but it'd be nice if instead of being able to build an obstacle pool, I want to build an obstacle pool from objects I load in from a file, right? So that's kind of where I want to go. I want to build my obstacle pool. I want to kind of do this, but I want to modify my obstacle pool so that it loads from a file as opposed to what we did before. Okay, that's one thing I want to do. So let's modify this build obstacle pool function. We already have this. So click, go to definition. And in my build obstacle pool, I'm just pushing back a bunch of brand new obstacles, but there's no information about these obstacles. So how do I read from a pool? Well, the first thing is, so again, I'm modifying the build obstacle pool function to do this. Derek says the result looks like range. Is that a line of sight? The result looks like range. Sorry, before we go into that, I'll answer Derek's question. So, Derek, do you mean that when I click this on, as an example, range from the target to this? Because right now the range is 1,000, but if I reduce this, you can see that as I reduce it, there's less and less objects. This is kind of a look at that, how it becomes almost like a circle of nodes around the target that has line of sight. That's what this path node line of sight does. If I increase this, you can see if I increase this number, it kind of increases the potential line of sight from the path node to the target, depending on if it's not blocked by an obstacle. That's what it does. Okay, hopefully you understand that. So let's go to this bit. So what I want to do, I want to load from a file. And the way it looks like is I want to say standard, let's look at our if stream. So our input file stream is what that is. I want to call this an in file, which I'm going to say .. It's going to be assets/data/obstacles.txt. That's the file that I'm going to read, and it's going to be saved in something called an in file. Okay? Next, so I'm just going to go down here. I'll do a while loop, and I'll say while not in file dot end of file. So if it's not the end of file that I'm reading, then what I want to do is I want to say standard cout, and let's output the obstacle. So here's our obstacle. We can show this loading. Okay. So we load the obstacle, right? And we're going to say obstacle pointer, right? Obstacle is equal to a new obstacle. So that's where we're going to add it in. And we want to create some, remember we've serialized our file. So one thing to note is whenever we save information on a file, like for example in data, we have this obstacles.txt. What we've done here is we've serialized data for information about the file. So we've saved it as information followed by a space, followed more information, followed by another space. And this is X, Y, width, and height. This is the information we have. We want to set up the way we read from a file, the same way we wrote to the file. So we want to deserialize our data. All right, so we want to say float X, Y, width, and height. So this is the same way the file is organized, because we want to deserialize everything. And what we want to say is from the in file, we want to stream to X, stream to Y, stream to W, and stream to H. So we want to read data from the file line by line. That's what we're going to do, okay? And we're going to say that, hey, obstacle, the obstacle we just defined, let's get transform dot position, and we want to say that that is equal to a new GLM vec2 where we pass in the X and the Y position. And then we're going to say, hey, obstacle, let's set width, or we did that to the width, whatever the width is. And hey, obstacle, let's set height to the height value. That's what's happening there. And then we're going to add child the obstacle to the scene, and we're going to put it at layer 0 to make sure it's at the bottom of our layer, right? And then we're going to say m_p obstacles, and we're going to push back the obstacle itself, whatever that obstacle is. And then finally, after we've read the file, we're going to do an in file dot close, so we can close the file off properly and no problem, which means that this little for loop that we had before, where we had a set number of obstacles, which was 3, is going to go away. So goodbye, obstacles. And that, my friend, is our build obstacle pool, where we're actually not just building the obstacle pool, but also reading from a file. So we kind of doing 2 at once. So really it's read file, read obstacles from file and build pool. That's kind of what it should be called instead. But for now, we're just going to keep it as build obstacle pool. I'm also going to respond to this little underline, which means that it's asking us to make it an auto, something that looks like this. Typically, I don't like this form. I don't like it where I have X, Y, width, and height. Realistically, we should be calling these width and height instead of this. We could also use multiple lines here. I'm just doing this to save room. Save. So that is our load from file, right, is what we're doing. And the idea here is in our start function, let's go to our start function now, really quickly. In our start function, instead of me having to do all of this here manually with each of the obstacles, we don't want that. We want to build the obstacle pool, which allows us to get everything. And we don't have to do this anymore. So these can be deleted because we've already done those things inside of my build obstacle pool. So now it makes it a little bit cleaner. It looks like this now. Okay, that's what it does. So if everything goes well, we should be able to run everything and we should see a full, kind of everything should be running. Let's take a look and see how that looks. Hey, look at that. Okay, so that's pretty cool. Well, I probably want to move my target around so it's not on top of this really weird obstacle, right? So maybe my target can be moved somewhere else. Let's try that again. So we have it at 600 and 300 and at 150 and 300. And that's okay for my starship and my target. We probably want to pull it back instead of 600, maybe something like 550. So let's start off with our target at something like 550. And let's try that again. So run it. And so it's not overlapping. That's the idea behind this. Okay, so it's not overlapping with this little thing here. So it successfully read all these things in. That's the thing that it did. If I look now at this, and if I toggle grid, you're going to see that only the grid, the path nodes that are aligned with, have visibility towards the target itself, as an example, that they have line of sight. Okay, and this is pretty cool. Let's do a couple things here, and let's move the target around. So what if I move the target up? You can see that it changes. Again, it's like casting a light. Imagine if the light is being cast, a green light's being cast by the target. It's kind of like that, right? If you look at it in reverse. And only the nodes that can receive the light are the ones that are turning on and turning green. If I change it to line of sight for the starship, then only the blue, imagine the starship is casting a blue light, right? A blue light that's being cast. And if I move the starship around, so if I move it kind of, up here, right, you can see that the blue light is going to hit only the nodes that have range. And if I move it high enough, if I move the starship up enough, then it not only has that, but it also has line of sight with the target. See that its own line of sight turns green. Okay, so that's kind of cool. So that's reading from a file, and we accomplished that. Let's put that up on GitHub. So we'll say clear CLS git add dot git commit -m. We'll say red obstacles from file. Git push. Okay, getting closer. All right, so let's take a look at the stuff that we've done. So we've removed the individual obstacle references. We did that. We added all line of sight helper functions. We did this piece. We did this piece. We set up a switch case. We're going to fix that in a second. In the start, removed all the obstacles. The GUI functions we made it work. And we checked everything so it does this. So we've pretty much done everything that's required for this lab, and not bad timing in terms of how we've done it. Now, the only thing I'd like to change, which is something that I think is important to do, is this idea of if I go back to my placing.h, we have this line of sight mode. So I want you to think about this now. If I Build obstacle. Sure, I can do that. No problem. Let's go there. Go to definition. Here it is. We've done it all, but it'd be nice if we have a enumeration for this stuff instead of our 012. 012 is really not descriptive. It'd be nice if it was more descriptive than what this is right now. Okay, that's what it would be nice to have. All good, Derek? You should be good to go. So now there's a problem, and I want to talk about this problem before we stop for the day. Remember that placeScene.h, if I made this a line of sight mode, if I called it line of sight mode and it's an integer, even if I made an enumeration, let's add an enumeration here. I want to talk about this as an example because we have a problem if we did this. So here's our enums. And we have collision shape and a heuristic and mouse buttons, scene state, shape type, sound type, tile neighbor, tile status, tile type, and a bunch of other stuff, right? We can have whatever we want. Let's make a brand new file, add new item. So we're going to add a new enumeration. Remember, enumeration is just a .h file, right? And we're going to call this what? It's like line of sight mode. Okay, so we'll call it that, line of sight mode. That's what it would be called, right? And if I make sure that it's added into the right spot, so it has to be, we have to browse to our SRC folder, right? So the folder location or the target down here on location should say SRC. If it doesn't say SRC, it's going to go to the wrong folder and you'll never be able to see that file. Click add. And just like we did before, we've called this thing line of sight mode. So again, it's like if not defined line of sight mode, then define it. And we're going to say end if, right, where we defined line of sight mode. Okay, I'm just going through this with you so to talk about this. And what I want is an enum class. Notice what we've done here in event.h is we've created enum classes. All it is enum followed by class followed by the name of the enum. Okay, so the exact same thing we're going to do here. We're going to do an enum class, where we're going to call this line of sight mode. Okay, that's the enum class name. And we're going to have in here the three modes, okay, that we had in here that we talked about in the play scene. Visible to target, visible to player, visible to both. Okay, that's what it's going to be called. So line of sight mode, we'll call this visible to target. Again, very descriptive is what you want to do here. Visible to ship, that's the player, and then visible to both. So the line of sight to target, to ship, to both. Really what that's I can take the visible out because that is really what we want to do. And if you want to go further, line of sight mode, target, ship, and both is also something you can even further cut down because if we look at this, that's kind of descriptive enough. Target, ship, or both. All right. And the reason why I went through that exercise with you is when you make, you will make enumeration classes for yourself in your game or in your scene. Make sure you think about simplification. So target stands for 0, ship is 1, and both is 2. Nice. How do I use this now instead of that that integer? Issues, my friends. Or is it issues? So up here at the top, what I want to do is I want to include, right? And we want to do the same thing we just made, which is line of sight mode. Here's line of sight mode. Now, danger. If I was to change this line of sight mode, instead of it being an integer, if I change it to a line of sight mode, that's okay. We can get rid of the definition that we have here because we don't need that. This is self-explanatory now, line of sight mode. My problem is it messes up stuff in my placeScene.cpp, creates errors in a bunch of places. So here at the top in our switch case, it clearly, we need to update these. This will be, again, line of sight mode, and then this would be just the target, right? This is more descriptive. It actually means something to you. Line of sight mode, the ship. Line of sight mode, both, right? And we don't need this stuff anymore. We don't need the descriptions because our code describes itself, really. That's a great thing about this piece. So this, nice, everything's beautiful, right? Okay, how about in the start scene? So I'm just going to go here to the next error. This is the next error here. And in the start scene, we don't do this. We say that it is an enum. Line of sight mode, we're going to set to line of sight mode to the target. That's the default, okay? Nice. And now let's go to this part. And we're saying the line of sight mode is equal to the target. So again, it's line of sight mode to the target. There we go. And we can compare that. We can say line of sight mode to the target itself is this. So far, so good, right? Okay, so far, so good. Any issues that you might see if I did this line of sight mode to the ship? What are your thoughts? Is this better, worse? What are your thoughts, guys? You can see there's some duplication still, right? And this is line of sight mode to both. Line of sight mode to both. Any problems that you foresee with this kind of thing? Derek says, of course, it's better. I like it too. I'm pointing this out because sometimes what we do is when we start coding stuff, we get moving and we start thinking about stuff and we get locked into this like thought that, well, I need some way of doing stuff. In your mind, whenever you think about switching from 0, 1, 2, when you have a number that you want to keep track of, a state that you want to keep track of, it's always better to use an enumeration. That's what we want to do. So let's try this now. Now that we've modified, we've added an enumeration, let's modify this thing to see if it works the exact same way or better. Okay? So these are our modifications to make our code better, is what we're doing here. Nice. And if I turn that on and I turn the grid on, and if I click this, then you see it's the same effect. No difference. Okay? No difference. Wonderful. Excellent. Yeah, that's the way it is. Now, is there a way, I'm going to pull this out the next one. Let's put this up on GitHub. So we'll say git add dot, git commit -m, and we'll say added line of sight mode enum is what we did. Oops, spelled it wrong, but who cares? Git push. All right, that's what we did. Nice. How do we make this better? Because look, line of sight mode, target, and it's like repeating. Is there a way of doing something better here with IMGUI, like I mentioned before, than doing this? I like it too. I like it too, Derek. Well, we did this, right, with our radio buttons. So we did this part. And really, if you think about it, right, I have a bunch of radio buttons. And do we really need this active text anymore if we can use radio buttons? So there's another way of doing it. Remember if I run the code now in our IMGUI, we certainly can use these and have this little active thing. This is kind of neat, a neat way of portraying this. Or we can have an enum where I can kind of, or sorry, a radio button where I have 3 radio buttons, 1, 2, 3. I can just choose one of these radio buttons and it'll do the same thing as all of this. Let's see if we can do that. So again, let's think about this. Instead of an IMGUI that says line of sight button, let's copy paste the one from where it says player input. I'm going to copy paste that one. And I want to put it underneath this separator right here. So it's another option for IMGUI. Because sometimes what we do is, guys, is we just accept what the professor does. But I want you guys thinking about ways of making your debug stuff, the debug center, even better. All right? All right, here's something. Radio button, it says, I have something called a current input type. A current input type, that is the radio button. If I go back and if I go to definition for current input type, it's an integer. Now this is where we can get into trouble and why we can say that maybe we don't need that thing the way it is, the mode. Because in our radio button takes 2 things. Radio button takes a label as well as an integer pointer. Okay, an integer pointer. And then a button, whatever the button is going to be. Okay? So if I was going to change this, let's just try it again. I'm going to keep these. Okay, I'm not going to move these out for a second. And let's just make a separator to show you the difference. So let's just put that there. And I want to change this. Instead of player input, we're going to call this path node visibility, all right, or path node line of sight. And we can say here it'll be the target. This one will be the starship. And that will be both. Now, this part is got to be line of sight mode, but the type is wrong. It should be an integer, but we want to, but right now it is a line of sight mode. We want to cast this somehow. We can do a static cast. Oops. Static cast as an int. We want to static cast this as an int. Can we do that? Can I static cast the line of sight mode as an int? Can I do that? And it says that if I hover over, it says it's okay with this, even though it's giving me this little error, right? This problem it's doing, it's just saying, hey, there's an error. It might be an error in Visual Studio, the way it's updating, as opposed to this. Let's try it again. So if I took these three, and if I static cast each one of them, that's how we could think of it working. But why then do we have this problem? Why do we have this problem? Why is it saying this? It's not really giving us an error. If I hover over here, it's not saying there's a problem. Is there another way to write this? By the way, it says basically that my static cast int, it says I'm changing the line of sight mode. So this is like the radio button. It says radio button, my integer value, and then my button. It says my button static cast as it says my integer input type is keyboard and mouse. Okay, that's what this piece is. So when my radio button is checked, that's what the radio button does, right? Then I'm making a change, right? I'm converting my keyboard and mouse, because I kind of did the same thing here, static cast keyboard and mouse. I'm converting it to, I'm selecting the input type. I'm saying the input type is the thing that is being selected. Okay, whatever the 0 is, 0, 1, 2, it's being set to this, right? Well, really what I want to put in here is I want to set the, now I'm static casting these as an integer, but I want to use the, whatever these types are, right? I want to do the same thing. I want to take the same mode, believe it or not, and I want to do this, right? I want to set this in there as well. So this is the thing I want to do. I want to say this static mode line of sight. I want to kind of cast this in here. And that should be a curly brace, right? I think that's what I need. I think I need an extra closing bracket to make this work. There we go. So that's what I want in here. I want to kind of close this off, and I want to close this off. So that's the thing I want to check. So whatever my line of sight mode is, whatever I select, I want to convert this to this, and I want to pass it in. Yeah. Right? So why am I getting these errors here? Is it going to even compile? And I'm not even getting errors here at all. Well, the reality is that this is what it looks like, path node to line of sight. Nothing is selected by default. Notice that all of them are selected. And I can't select any of them. That's what it does when I do this funky stuff. All right, so going back to this, path node, my line of sight mode, depending on 0, 1, and 2, I'm converting it, right, from each one, and I'm putting it back. What's the way that I want this to be done? So notice it says keyboard, mouse, and game controller, or whatever. I'm going to convert it to an integer and set it here. What I'm really doing is, if you think about this, this should be 0, right? I want to cast this as 0. And I want to cast it back to, instead of an integer, I want to cast it as whatever it's going to be, 0, 1, or 2. This is kind of what I want to do, right? And I want to save it in this thing, all right? But that means I need to static cast it to a line of sight mode. So I'm going to kind of say something like static cast, or just to make it so it kind of is that. So I would say, well, if it's this, then it's going to be M underscore line of sight mode to line of sight mode to the target, right? And I want to static cast this piece back to an integer. So static cast this, okay? And I'm just going to copy this piece. You'll see what I'm talking about in a second. Hopefully you'll understand. This will be to the ship. Oh, I don't even know how that built the ship, and this is the both. There we go. But we're still getting these funky errors, and why are we getting them? I want you to talk to me about this, because sometimes you get this stuff and it bothers you, as it should. And you can see right now it's target. If I switch to Starship, it also moves this one, or both. It also moves this one. I can toggle it on, and it works exactly. It works here, but if I go both, it doesn't work. I can do Starship or this, but I can't do both unless I click this. So why can't I click both? I can do this, I can do this, but I can't do this. Almost there. Let's take a look and see what this crazy stuff is. So why not both? Target, ship, but not both. That's why I put this here. Why not? Well, first of all, let's comment out all of this stuff. So just for our our sanity, right? Let's just comment out all of this piece right here. Let's comment all this out, and let's see why this, and then I'll stop for the day. I want to talk about this because I want you guys to, again, to understand IMGUI a little bit more. So first it built, and it shouldn't, because we had errors. And we have this, and we can't get to both. Even though I want to choose both, I can't somehow do it. I can show this, and I can do one or the other, but not both. Why? Why can't I select both? And why can I even do this? Should I even be able to do this thing? Because Starship is blue and target is red, but not both won't even show up. Let's take a look of what the format looks like. So I'm static casting. That's what I'm doing, static casting. And this is a problem. It's not liking the static cast stuff. I'm static casting my line of sight mode because radio buttons require an integer pointer. And I'm static casting this entire thing. So what is it trying to give me an integer pointer to? Maybe if I put this whole thing, almost like the whole thing is something that I want to static cast, in your mind, you might think that, yeah, that's probably what we want to do. Okay, what about if I wanted to dynamic cast? Would that fix my problem? So if I said dynamic cast, and I want to dynamic cast it as an integer, well then, no, that actually creates other problems. So static and dynamic cast not working, right? Still giving me that weird error. Okay, what else? What other kind of casting can we do? Because really what I want is I want to convert this to an integer, this line of sight mode. I could do it the old way, right? So let's just rewrite this thing altogether. And I could redo it like this, where I say it's an integer and M underscore line of sight mode is an integer. I could do that. And then Visual Studio is going to say, nope, you probably want to use a static cast, or you can use a functional style cast. Let's use a functional style cast. And again, what we get is, you probably want to use a static cast. So what we did was correct. You static cast, but we get this really weird error. So what's the weird error that we're getting? What are we trying to do here? Well, funny enough, what we're trying to do is we're trying to convert and get a reference to this object. And up in here, right, for the object that we're going to try and get a reference to, which is line of sight mode. The reason why it's complaining could be that it's not initialized. So if we did this, that kind of initializes what that is before we get to this, which could be part of the problem. It isn't. Okay. What other things can we do to change line of sight mode? Because line of sight mode is this. We could create a temporary variable. This is another thing we could try and do. We could sit there and say, I want to make some kind of static variable, right, which is going to be called line of sight mode, right? And it's going to be of type int, okay? So something like this, a temporary variable that's very similar named line of sight mode. And we can say that that is equal to the m underscore, we can do a static cast, int, and then m underscore line of sight mode. We can do that, right? There we go. So that kind of takes care of this piece because we're doing it every frame anyway, right? And then in here, we can just put in that variable, which is line of sight mode. And you might think that this is okay, and that takes the place of this, and it doesn't complain anymore. So why is this okay? Why would Visual Studio not like what we're doing, but rather do it like this? Well, even if we did this, I'm just going to put it out there. If I change this, will it really change what it's supposed to change? Okay, so let me just put this out there. So if I ran it and I go back out, yes, I made a variable like so, and it's called line of sight mode, and I'm modifying it. But, well, yes, it doesn't give me an error, but it also doesn't work. And both still no-go. Okay? Both still a no-go. So we static cast from both to this, where both is a 2, ship is a 1, target is a 0. Okay, so that is a way of doing stuff. So we can static cast this back and forth. And yes, we could probably go the other way again. If you were thinking about that, you could say something like, all right, I want then line of sight mode. If you want to, kind of do this, line of sight mode is going to be equal to my line of sight mode, this one here. And we know we need to static cast it because it doesn't make sense. We can say static cast, right? We can static cast it to our line of sight mode, I can try doing it this way. So we're casting it back the other way around. So we can kind of do this, which would solve one of the problems, but it's not solving this problem. This problem is not being solved. Why not both? Why not both? Nice. So again, this can work, right? And if we turn it on, you can see now that it's functioning again, but not this one. It wouldn't even light up. Why can't I do it? Derek, tell me, help me. Guys, anybody. Why can't I? 3 different options, 3 different radio buttons, kind of cast in the same way. It saves me all this code. Man, I want to be able to do something like this because it makes more sense for me to do it, right? It's because I want to say that line of sight mode both is equal to this. And, well, when will this be the case? How come I can't click this button and make it go? Why? But what if I had something else? What if I had another case in here? Like, in my, I'm going to go back to my enum, okay, for a second. Here's line of sight mode. So it's target is 0, ship is 1, both is 2, okay? Let's make another one. Let's make another one called, number of types. Number of modes. How about that? Number of modes actually gives me a 3. Huh, okay, number of modes. And if I go back to CPP here, and if I go line of sight mode, I'm still doing the exact same thing with this last radio button, but something is not right. Something is not happy when I do this kind of stuff, right? It's like I'm trying to do this, but it didn't work, right? It worked for this one, right? Well, why then doesn't it work for this one? IMGUI is weird, right? And it does stuff that you sometimes won't be able to predict. So let's try this out and run it. So both still doesn't light up. Starship lights up. Okay. And what if I put in, instead of both, I put in number of types? Because that's a thing now, number of modes, which is 3. There's 3 kind of like compute, right? So let's see what this does, right? And does it crap out if I did this? So I said, okay, I want both. Both still can't light up, 1 and 2, but the next one, for whatever reason, doesn't work. So Derek says last. I'm not sure what you mean by that, Derek. So both target or this. Let's change this back to, just to show you some, it doesn't matter what I put in here, it's not going to work. Okay. So target, ship, and then finally I'm going to go to both. Okay. Well, remember what IMGUI is. IMGUI is an immediate mode UI that keeps on updating, right? So if any time I change stuff, if I'm changing stuff to 0 or 1, if there's any time I'm doing that, where it can't be a 2 for some reason, it's either a 0 or a 1. If there's any place down here that does that, that will mess up. What if I did it the other way around? What if I changed the order of things? If I said, okay, let's take this out, and I want to put this up here, right? Line of sight mode both. Okay, so line of sight mode, and go back up here. I just changed the order, both target and then ship. All right, so it should say target. There's both, right? And if I click on both, still doesn't work. Target and ship are okay, but both, nope. What? So what happened? Why is this not happening? Okay, let's do the same line. So say IMGUI same line. So they're all on the same line, let's just say. And this one won't be on the same line because we'll make that the ship last. All right, so there's both. Remember what both is. Both is a 2, right? Both is a 2. I'm saying let's assign both the number 2 to line of sight mode. Line of sight mode is here. Line of sight mode is going to be set to the line of sight mode over here. And it's going to be cast as the other line of sight mode. So 2 instead of 1 or 0. Okay. So why not? Why not? And it could be IMGUI that's causing it's like a glitch in IMGUI. It could be that. But I noticed it before when I tried this out last time and I was going to do the demo with you. It just wouldn't go to both. In fact, it won't go to anything else. If I said instead of both target and starship, target and starship, target and starship, okay? And I choose both. So I changed the name of the button. Okay, I just want to point this out here. And then you're gonna be mad at me when I do this, okay? Now it works. Why? Because of the name of this thing, my friends. Because notice how this one here is a radio button and it uses both. Because both has been used, you can't do it again. And that is something that I wanted to talk about today. Because we can, kick around why this isn't working and all that kind of stuff. But the real reason isn't because of any enumeration issue. It's IMGUI. IMGUI uses the name you give these to create key value pairs. So target and starship is not enough. Both, if I put something like both target and starship, right? That is going to compute too. That's going to be okay, right? Which means that if I go back to the line of sight mode.h, I don't need number of modes. That was just my test to show you that that doesn't work. Good. And this is significant. This works nicely as an enumeration. It works nice. It kind of shows everything. It maintains the same key exactly. That's what happens. So it's key value pairs, and we're updating the same key over here. And because this is input all, it's going to always be 0, 1, and that's it. So now we can go Starship. So if I go here and I turn the grid on, I can turn the Starship. I can go both, right? And you can see that that is that, or I can go back to target. And I think this is a little bit sleeker as an enumeration as opposed to that bunch of buttons, okay? Which means that we can get rid of all this code, right? So this is what we wanted to do today. All right, I know we've gone over time, but I wanted to talk about this as something that I wanted to start off with you guys with. Let's put this up on GitHub. We'll say updated git add dot git commit -m, and we'll say updated IAMGUI or GUI function with enum, or with with a radio button. Okay, Git push. That's everything that I wanted to do with you guys today. I wanted to talk about IAMGUI because some people have issues understanding how this works. So again, you can see that keyboard, mouse, game controller in both. But once I use both in IAMGUI, I use it forever. I can't use the same key because the radio buttons depend on key value pairs. Okay, so both is almost like it sets up a series of radio buttons. You can never have any control in IAMGUI that's named the same thing. Please be careful about that. All right, so that is what I really wanted to cover today for your lab 6.2 notes. Let's talk about notes. Let's see if it runs. So this is what you should get at the end. And guys, if you got everything that I have at the end, check mark, please. You should have this. So I should be able now to toggle the grid on, right? I can see different colors for the grid. I should be able to move my ship around, and notice when I move my ship around, and if I change my Starship as the path node line of sight, that only the blue areas here, the blue nodes, have line of sight with my Starship. If I move any of these things around, it will affect the line of sight, right? If I overlap them, I can do that. I can overlap any one of these things. I can also change this one here. Right, once I notice how these nodes are blocked, but these nodes are open. And if I move this up, let's do, I think it's number 3 or 2. Yeah, that one. I move this there. You can see that I've nicely created an area where only these nodes here have line of sight with the Starship. Okay, only those nodes. And the bottom one, let's move that over again. No, that's good. Let's move that there. Let's move the very bottom one. Maybe that one is this one. That's the bottom one. They're not put in any order. It looks like there's a target and there's this part. Should be able to control all of them. There it is, that one. So that one I want to move over a little bit this way so I can box it in so you can see that these are the nodes that each of the obstacles have. All right, so kind of neat. So that's the control you should have. Yes, exactly. All right, so for the report, let's talk about the report. I know I'm going over, but I want to kind of record this for you so you have it. So for the report, the lab report looks like this. Here's lab report for lab 6. So a couple things, right? So version control is worth 0.5, ship and obstacles 0.5, path node class 0.5. We made that grid of path nodes 0.5. A line of sight check from the ship is 1. We're giving it 1 mark. And now in this week, obstacles from a file 1%, agent line of sight checks 1%, and ship to target path. This is for students to do. This is for you guys to do by yourself. Is you draw a path from the ship to the target without flaw. What I recommend for this is some kind of button. It tells you some instructions here. Some kind of 4th button or another button in IAMGUI should kick off this calculation and draw this button. You can also redraw. You can use anything we showed you in this lab plus any other code you need. There could be at least one obstacle in the way in order to have to do this path. And if there are no obstacles in the way and the path to the target is clear, just output in console that the path is clear. Okay, so some instructions on what to do is right here. I recommend, kind of doing this. It'll give you a chance to play with the stuff that we've talked about today, and you shouldn't have any issues. Okay, questions before we end for the day, because that's all I want to talk about today for our Lab 6 Part 2. And this is kind of a Lab 6. Okay, so constant GUI ID is equal to window get ID label. If item add total. Okay, I'm not sure what you're saying there, Derek. Now make scene. If item add total turn false. Oh yes, okay, yes. Sorry, there we go. That's the ID. It's like true. It's key value pairs. All right. Any other questions around this before we go for the day? I think you guys should have everything you need at this point. And that's why we've kind of done this. So if there's no other questions, that's it for today. Thanks, Marco. Thanks, everyone, for being here. For the people that are just joining now, remember what we talked about earlier, that what we'll be doing is you guys can join the 1 o'clock class. You don't have to wait until the 3 o'clock class to join. So that means so Marco, Kayla, Kieran, Abu, you guys should have joined 1 o'clock, and then you guys could have seen this entire thing. Now, worst case scenario, what you can do is watch the video that I've just finished recording, and you can continue. I'm going to stop recording now and then take any questions you might have. So let's do that now.